Okay, so today is day 2 of section 6 or lesson 6 of chapter 1, and still other types of equations. Today they're going to be radical equations. Now just keep in mind that we've done some of these. Like for example, if I gave you x squared equals 4 and I ask you to solve this, remember what we did was we square rooted both sides, which canceled the square, and that gave me plus and minus 2. Now, keep in mind that when you solve for a variable, you get both answers. But if I were to have asked you just to simplify this, you only tell me the answer is 2. So know the difference. So when you're just simplifying a radical, you're just going to get the positive answer. But when you're solving for an x squared, you're going to get both plus and minus. So know the difference. Let's see. So also keep in mind that we learned back with the exponents that we could turn the square root of x into x to the 1/2. And then to cancel that, what you're doing is squaring it. And then again, this would become 2/1 times 1/2, and it's just x to the first. This is sort of what we're going to do in this lesson. So let's go ahead and try it. Now, these are just screenshots from your textbook. We're going to be applying power property. We're also going to be solving these radicals. Step number 1, and they have little steps here. Step number 1 is to isolate the radical. Then the next one says to raise each side of the equation to a power that's the same as the index. So all of the examples we're going to do today are going to be square roots. So the index on a square root is a 2. So we're going to be squaring both sides to cancel the radicals. Then after that, you're going to solve what remains. It might be linear, it might be quadratic. Most of them are going to be quadratic that we're going to be solving. And I think all of them can be factored. Now, keep in mind, technically you don't have to factor. You could use completing the square or quadratic formula, but trust me, factoring's a lot faster. Then after we get our answers, just like before with the fractions, the rational equations, we have to check our answers. So try these. So these are going to be square root equations today. And again, step number 1 is to isolate the square root or the radical. So I need to get this to be the only thing all by itself on either the left or the right side. So I'm actually going to add the square root of 15 minus 2x to both sides. And now I'm left with x equals the square root of 15 minus 2x. Now, my goal here is to solve for x. Notice I've got an x on both sides. So now, once your radical is isolated, step number 2 is to raise both sides of your equation to the same index power. So again, it's a square root, so I'm going to square both sides of my equation. I'm keeping things balanced. Whatever I do to the left, I can do to the right. Remember, when you square a radical, it makes it disappear. So the 15 minus 2x comes out of the square root symbol, or the radical sign, and then this side stays x squared. I now need to put it into a form where I can solve for x. So I'm going to put it in standard form, and then I'm going to factor it. So I'm going to add 2x to both sides. X squared plus 2x equals 15. Move the 15. X squared plus 2x minus 15 equals 0. Now, at this point, you could do quadratic formula, completing the square, or factoring. This one's nice and easy to factor. Factors in negative 15 that give me positive 2. That's going to be x plus 5 and x minus 3. I now set each factor equal to 0. And I solve for x. Subtract 5. Add 3. And now remember, you need to check your answers. Last step is the check. It is mandatory. So we take the original equation, x minus 15 minus 2x equals 0, and I plug in. I got to do it twice, yes?
So if we don't check, that means one of them could not be right?
Correct. All right, now, when we do the check, they both might work. So they both might work, they both might fail. One might work, one might not. So you have to do the check. What I found in the past is students remember to do the whole solving process. They get to this step, but then they forget the check. So keep in mind, you have to do the check. So now let's do the check. Again, I have to check them both. So if I put negative 5 minus 15 minus 2 times negative 5, negative 5 minus 15 plus 10, negative 5 minus 25, negative 5 square root of 25 is 5. Notice it's negative 5 minus 5, that gives me negative 10. That does not equal 0, so this tells me that this one is out of there. It does not work. Now, don't automatically assume that as soon as you get one to fail that the other one is automatically the answer. You must check them both. All right, so then the next one. Again, same original problem, but now we're plugging in 3. 3 minus 15 minus 2 times 3. I'm trying to see if it equals 0. So 3 minus 15 minus 6. 3 minus 15 minus 6. 15 minus 6 is 9. Square root of 9 is 3. 3 minus 3 is 0. It checks. This is my good answer. So again, both could work, both could fail, one could work, one could not. It all depends on when you plug it back in and do the check. Next example, again, step number 1, isolate the radical. So I need to add 3x plus 18. X is over here by itself, 3x plus 18. Step number 2, raise both sides to the power that's equivalent to the index. The index is a square root, it's a 2, so I'm going to square both sides. Again, squaring this square root makes it cancel. I'm left with x squared, 3x plus 18. I now need to get this thing in standard form so I can factor it. So minus 3x, x squared minus 3x equals 18. Subtract the 18. X squared minus 3x minus 18 equals 0. Again, at this point, factor it, quadratic formula, completing the square. It's easy enough. It's got a leading coefficient here of a 1. So all I have to do is look for the factors of negative 18 that give me negative 3. Those are going to be negative 6 and positive 3. Again, set each factor equal to 0. X equals 6 and x equals negative 3. Again, check is mandatory. We need to plug these in. So we're going to go back to the original. My original was x minus 3x plus 18. So 6 minus 3 times 6 plus 18. And I get 6 minus 18 plus 18. 18 plus 18 is 36. When I square root the 36, I get 6. 0 equals 0. This one checks. Now let's try the negative. So 6 minus 3, 3 times negative 3 plus 18. 6 minus negative 9 plus 18. 6 minus 9 equals 0. 6 minus, I did this wrong. It should have been a 3. Sorry. I plugged in the other number here. These are 3s. It should have been a negative 3, negative 3, negative 3. So negative 3 minus 3. Negative 3 minus 3 is negative 6. It's not equal to 0, so this one fails. So your only answer is x equals 6. This is where I talked about at the beginning when I said the difference between doing this and we square root both sides and we get plus and minus 4 versus if I just said simplify the square root of 16, you only get a 4. So you don't get the plus minus when you're just simplifying a radical. Again, step number 1 is to isolate the radical. Notice this one's already isolated for us. So all we need to do is square both sides. Now, this one's a little tricky. Pay attention here. Because notice I've got 2 things over here that I'm going to square. So I'm squaring this. And I'm squaring this whole thing here. So I'm foiling it. So this side cancels the radical, and the 4x plus 13 frees out. But this guy I got to foil. 2x minus 1, 2x minus 1. Don't just distribute the exponent to each term. You will get it wrong. So once I foil this, I get 4x squared. Outside gives me negative 2x, inside negative 2x, so negative 4x. Plus 1, and now I'm going to put it into standard form so I can either factor, use quadratic formula, or completing the square. So I'm going to move the 4x over. 13 equals 4x squared minus 8x plus 1. Move the 13. And I get 0 equals 4x squared minus 8x minus 12. Let me just go ahead and put the 0 at the back or the end. All right, so now I'm gonna factor out a GCF before I start this. My greatest common factor that I can divide all of these by is 4. Always remember to look for a GCF first. It'll make it a lot simpler. I can divide them all by 4. Make it x squared minus 2x minus 3. And now I'm only looking for the factors of negative 3 that give me negative 2. So this would become x minus 3, x plus 1. Again, set each of the factors equal to 0. Again, setting this 4 equal to 0, there's nothing to solve for, so you don't need to do it. But all the ones that have an x, we actually have to solve. Add 3. So my first possible solution is x equals 3. And then the other one is x equals negative 1. So again, remember, we are checking. So let's go ahead and rewrite the original. Yes. All right, so next, my original problem was 4x plus 13 equals 2x minus 1. So let's plug in the 3. Twelve plus 13, 25. 6 minus 1. Square root of 25 is 5. 5 equals 5. This is a good answer. Now let's do the same thing with the negative 1. So 4 times negative 1 plus 13. 2 times negative 1 minus 1. Negative 4 plus 13. Get 9. Square root of 9 is 3. 3 does not equal negative 3, so this answer is gone. So again, you can't get the positive negative out of that 9 because we're not solving for a variable.
Squaring 9 would make plus or minus 3.
Not when we're simplifying. When we're simplifying, we're only keeping the positive root. If I were to have solved for it, then I would have gotten plus minus 3. But if I just ask you to find the square root of 9, you just tell me 3. Good?
Can you go back up?
Yes. Let's keep going. All right. Now, here's where it's getting different. So pay attention. So again, my goal is to isolate the radical. So again, I'm adding the 1. So 6x plus 7 is now isolated, and I get x plus 2. Okay, now it looks like the same thing as last time. Square both sides. I've got to FOIL this right side. So the left side, the 6x plus 7, just frees out. But this one I FOIL. So it becomes x squared plus 4x plus 4. And again, put it into standard form so you can factor it. So what I did was x plus 2, and I FOILed it. X squared, 2x, 2x, 4, combined it, and that's how I got the 4x. All right, move the 6x. 7 equals x squared minus 2x plus 4. Move the 7. 0 equals x squared minus 2x minus 3. I'll flip it around. Set it equal to 0. So factors in negative 3, that give me negative 2. X minus 3. X plus 1. Set each of the factors equal to 0. Add 3. Okay. X equals 3. X equals negative 1. Again, here's where it changes. Notice all the other ones we did, the negatives failed. This time, they're both going to work. So let's check it. So, original problem, 6x plus 7 minus 1 equals x plus 1. So 6 times 3 plus 7 minus 1, 3 plus 1, 18 plus 7. I'll add 3 plus 1, 25 minus 1. 25 square rooted is 5. 5 minus 1 is 4. 4 equals 4. It checks. So far, so good. Now let's try the negative. So again, 6 times negative 1 plus 7 minus 1, and then negative 1 plus 1. Negative 6 plus 7. I'll simplify the negative 1 plus 1 to a 0. Negative 6 plus 7 is 1. Square root of 1 is 1. 1 minus 1 is 0. The negative finally works. So I actually have two solutions, and they both work. So again, notice I have two radicals. So I need to isolate one of them. So I'm going to actually just move this one to the other side. So now I have 2x plus 3. This is my isolated first radical. And then here I'm going to get 1 plus x plus 1. You're going to square both sides to cancel that first radical. Now, the right side's going to get messy because we have to FOIL that thing. So the left side was easy. The 2x plus 3 just comes out. However, this right side, the 1 plus x plus 1, I'm FOILing this. So I'm going to do first, and I get 1. I'm going to do outside, and I get x plus 1 under the radical. I'm going to do inside, and again, I get x plus 1 under the radical. And then when I do last, remember, a radical times itself just makes the radical go away. So I'm left with x plus 1. I now need to combine my like terms here. Now, remember when you add radicals, treat them like variables. So I could assume this has a little 1 out front, and this has a 1 out front. So this, when I combine these two, is going to become 2x plus 1, because I have 2 of them. Let me drop down the 1 plus, and then this. I can also combine these two 1s. So now I get 2 plus 2 times x plus 1 under the radical plus x. Okay, that's that FOILed answer. I'm now going to set that equal to my 2x plus 3, this thing over here. So I have 2x plus 3, and now I'm going to write this one over here. 2 plus 2x plus 1 plus x. My goal now is to isolate the radical again. So I need to get everything away from it. So I'm going to move the 2 over. 2x plus 1 equals 2 radical x plus 1 plus x. I now need to move the x over. Again, I'm trying to get the radical to be the only thing on either the left or the right side. Everybody with me so far? All right, my radical is now isolated. I can leave that 2 in front. I'm going to square both sides to cancel that radical. Now, notice there's no plus or minus in between here, so I'm just going to take this power 2, square the 2, and then when I square the radical, it disappears. So this becomes 4 times x plus 1. The left side you have to FOIL, and it's going to become x squared plus 2x plus 1. I now need to distribute and get 4x plus 4. And now move my terms together. Yes? Going. So now move the 4x. X squared minus 2x plus 1. Move the 4. X squared minus 2x minus 3. I am looking for the factors of -3 that add to give me -2. X minus 3, x plus 1. Set each of the factors equal to 0. Add 3. X equals 3. Subtract 1. X equals -1. Again, we need to check. Original problem was 2x plus 3 minus x plus 1 equals 1. So 2 times 3 plus 3 minus 3 plus 1 equals 1. So 6 plus 3, 3 plus 1, square root of 9 minus square root of 4, 3 minus 2, 1 equals 1. The first one checks. We have to check the second one. Don't assume because it's negative it doesn't work, because it does in this problem. 2 times -1 plus 3, -1 plus 1, -2 plus 3, square root of 0, square root of 1, 1 minus 0, 1 equals 1. It checks. I've got two good answers. Again, I'm going to isolate. So actually, it's already isolated. So I'm just going to square both sides. So square, square. This one I'm going to FOIL. So x plus 5 minus 2. X plus 5 minus 2. When I do first, I get x plus 5. It's freed out of the radical. Then outside's going to give me negative 2 x plus 5. Inside's going to give me negative 2 x plus 5. And last gives me positive 4. I'm going to combine like terms. This 5 and 4 is going to become a 9. So x plus 9 minus 4, x plus 5. Now I can set this equal to this thing freed out of the radical. So again, we're trying to isolate our next radical. I'm actually going to move this one over to the right so it turns positive. So I'm going to add this to isolate it. So x plus 9 equals x minus 1 plus 4 x plus 5. Move the x. X is canceled from both sides. Move the 1. 10 equals 4 radical x plus 5. I've now got the radical isolated. Square both sides. This becomes 100. The 2 goes on the 4, so it becomes 16 times x plus 5. I need to distribute the 16. And now move the 80. And I get 20 is equal to 16x. Divide by 16. 5 over 4 equals x. And again, you got to check it. So again, the original problem was x plus 5 minus 2 equals x minus 1. So 5 over 4 plus 5 minus 2 and 5 over 4 minus 1. I'm going to change my 5 here so it's got a common denominator, and I'm going to make it 20 over 4. Same thing here. I'm going to change that negative 1 into 4 over 4. So I get 25 over 4 minus 2. 5/4 minus 4 over 4 is 1/4. This becomes 5 over 2 minus 2. Common denominator, I can make this 4 over 2. What did I do wrong? Okay, so this is also under the radical from the original problem. So when I square root this, so this becomes 5 over 2, and this becomes 1 over 2, subtract 1 over 2 equals 1 over 2, it checks. So my answer of x equals 5 over 4 is a good answer. Yes? So again, isolate one of the radicals. It's already isolated, so we're going to square both sides. So 4x plus 1 comes out. I need to FOIL this thing, so I'm going to write it 2 times and FOIL it. So x minus 1 comes out. The last example, we're going to FOIL the right side. So after I do first, I get x minus 1. Outside, I get 2 times x minus 1 under the radical. Inside, same thing. And last gives me plus 4. I'm going to combine these like terms here in the middle. And then I can combine the 1 and the 4. Now let me go ahead and drop down what I got after I squared that left radical. And now I need to isolate this other radical over here. So I'm going to move the x over. 3x plus 1, 3 plus 4, x minus 1. Move over the 3. 3x minus 2 equals 4 times x minus 1 under the radical. I now have my radical isolated, so I square both sides. I'm going to FOIL the left. It ends up giving me 9x minus 12x plus 4. The right side, I square the 4. The x minus 1 drops out of the radical. I need to distribute and get 16x minus 16. Go ahead and rewrite my left side. I'm going to move the 16x over. 9x squared minus 28x plus 4 equals negative 16. I'm now going to move the 16 over. Nine x squared minus 28x plus 20 equals 0. I now need to factor this. So if I do the factor by grouping, I get 9 times 20, and I get 180. So I'm looking for the factors of 180. That will give me negative 28. Those factors are going to be 10 times 18, and they're both going to be negative, because when I add them, I get the negative 28. So rewrite the 9x squared minus 10x minus 18x plus 20. Again, it doesn't matter how you put them back in to make your groups, you're still going to get the same answer. So from my first group, my GCF is x. So then I'm left with 9x minus 10. Over here, my GCF is going to be negative 2. And I'm left with 9x minus 10. Put these two together. And then the 9x minus 10. And now set each of the factors equal to 0. Solve for x on the first one by adding 2. Solve for x on the other one by adding 10 first. And then dividing by 9. I now need to do a check. So again, I'm going to take my original for x plus 1, x minus 1 plus 2. I now need to plug in 2. Eight plus 1, 1 plus 2. Square root of 9. I can square root the 1, it becomes a 1. Square root of 9 is 3. 3 equals 3, it checks. So far, x equals 2 is a good solution. Let me do it again with the 10 ninths. So 4 times 10 ninths plus 1 under the radical is equal to 10 ninths minus 1 plus 2. 40 over 9. I'm going to change the 1 into 9 over 9. Again, change the whole number 1 into 9 over 9. 49 over 9. Over here, 1/9. I can square root these separately. This becomes 1/3 plus 2 over 1. Make a common denominator, make it 6 over 3. 7/3 equals 7/3. It checks. So my other solution of 10/9 is also good. So both of them work. So I have two answers, x equals 2 and x equals 10. Your homework is pages 144 to 145, 27 through 43 odd.